In this video, we will look at the basic operation and flow paths of Hivair's 4-way, 2 and 3 position DO3 and DO5 size solenoid-operated directional control valves. Note that the DO3 size valve combines flow from the tank channels on either end of the valve to one single tank outlet. But to better understand the valve, we will show it has two separate outlets like the DO5. The tank channels are connected using a twin-channel design with an upper and lower channel, greatly reducing pressure drop. Let's look at the basic components and function of the solenoid-operated directional control valve. There is a coil, core tube with a plunger, and a centering spring located on each side of the directional valve. Each core tube has a core immersed in oil that moves the plunger to shift the spool. On the standard valves, you can see the two large holes that allow the core to move through the oil-filled tube. Hivair offers a hydraulic shockless valve where the core is equipped with orifices to meter the flow and reduce the speed of the core by up to 4 times, whereby reducing shock, pressure spikes, and providing an even quieter operation. The standard valve will shift in approximately 20 milliseconds and the shockless valve will shift in approximately 80 milliseconds. Each core tube has a brass pin located at each end of the valve to function it manually. Using an Allen key or a cylindrical item smaller than 1/4 inch in diameter, press the override pin to manually shift the valve. Pressure created by the tank flow and centering spring will be working against the pin, so ensure enough force is applied to fully shift the spool. To wire the valve, you will need to provide power to the solenoids using a 3 or 4 conductor cable. For this example, we are showing the wiring setup for a 3-position double solenoid valve. There are the 2 hot wires shown in red and black connected to solenoid A and solenoid B, usually coming from a switch. The common wire shown in white is connected to the jumped contacts. And last, we have the ground wire shown in green. When power is applied to a coil, its plunger pushes the spool to the shifted position, and thus changing the flow path of the valve. To prevent damage to the valve, always ensure only one coil is energized at a time. Once the coil is de-energized, you can see the spring returns the spool to the de-energized neutral position. The lines with gauges labeled A and B are the work ports typically connected to a hydraulic cylinder or motor. We will look at the main stocked spool types, but note there are several more flow path options available on Hivair's website. The first spool we will look at will be the H spool, or all ports common spool. When the valve is in the de-energized or neutral position, we can see that the P port is open to all ports and will flow to the path of least resistance, usually tank. The tank channels are connected using a twin-channel design with an upper and lower channel, greatly reducing pressure drop. When we energize the coil on the left side of the valve, solenoid B, the plunger pushes the spool to the shifted position, and now we see flow from the pump being directed from the P port to the B work port, with the A work port now open to the tank T port. When we energize the solenoid coil on the right side of the valve, solenoid A, we get the opposite operation, with flow from the pump being directed to the A work port and from the system to work port B and back to tank. The B spool, or all ports blocked spool, stops all flow in the neutral or de-energized position. You can see the spool covers and blocks all of the ports not allowing flow through the valve. When energized, the valve performs in the same manner as the H spool, opening up flow from P to B and P to A. The F spool, or motor spool, blocks the P port but allows flow from A and B to tank in the de-energized position. You can see the P port is blocked with the spool, but A and B are open to tank. When energized, the valve performs in the same manner as the H and B spools, opening up flow from P to B and P to A. The T spool is the opposite of the F spool, and in neutral, the P port is open to A and B, and the T port is blocked. When energized, the valve performs like the previous valves, opening up flow from P to B and P to A. The K spool blocks incoming flow from the pump while also blocking the work port B, while work port A is open to tank. When energized, the valve performs in the same manner as the other spools, opening up flow from P to B and P to A. The C spool or tandem center spool is the only spool that is machined to allow flow through the center of the spool through small radial holes. For this reason, flow is reversed when the same coil is energized on the aforementioned valves. To overcome this, the coil is simply renamed, as you can see by the symbols shown. You can see the coil on the left is now the A solenoid and the coil on the right is the B solenoid. When the valve is in the neutral position, we see flow being directed to the P port and through the tandem spool to the tank. In this position, the work ports A and B are being blocked by the spool. When we energize the coil on the left side of the valve, solenoid A, we see flow going from the P port to the A work port, and the B work port is open to the tank. When we energize the solenoid coil on the right side of the valve, solenoid B, we get the opposite operation, with flow from the pump being directed through the spool to the B work port, and from the system to work port A, and through the spool and back to tank. Now let's look at the single solenoid two-position valves. The first spools we will look at will be the 1A and 1AY spools, or spring offset, closed or open in transition. In the de-energized state, the spool is in a spring offset position with P flowing to A and B open to tank. When energized, the spool will shift to the other flow condition where P is now flowing to B and A is open to tank. During the shift, the spool will have a transition or crossover condition that is either open or closed. These transition conditions are unimportant in most circuits, but can cause shock, drifting, or cylinder regeneration under certain circumstances. Contact a high-VAR application specialist for more detail. Now we will look at the single solenoid, two-position, spring-centered valves. In the de-energized state, the spool is in the spring-centered position, showing the 5F spool for reference. When energized, the spool will shift to the other flow condition, where P flows to B and A is open to tank. Unlike the 1A or 1AY, there is no transition or crossover condition, since the spool never moves past center. Note, this valve is available in all of the standard three-position flow conditions. All of the two-position valves can have the code R added to the spool code to provide the opposite flow condition from standard. For example, the 5BR spool code will still be the B pattern in neutral, but since the coil is now on the right side, when energized, the flow condition will be P flowing to A and B open to tank. That concludes this lesson on the basic operation of high-VAR's solenoid-operated directional control valves. If you would like further information on these valves or any other of high-VAR's extensive selection of hydraulic and pneumatic equipment, please contact high-VAR.